Right, hello everybody, thank you for coming. My name is David, welcome to the second of our Soho school nights. And specifically, we're going to be talking all about text. So we've got 4 speakers for you tonight. I'm the first, and we'll take good care of you. Hope you've all charged your glasses and ready for the first couple. What we'll do is we'll have a couple of speakers, and then we'll have a little break and give you all a chance to refresh yourselves and into the loo, and then we'll have our next couple of speakers. And then later on, right at the end, we'll have an opportunity for us all to have a sort of bit more of a chin wag and to throw some ideas around and sort of hear if anyone's got any sort of big burning general questions that they want to throw at the people who've been speaking and whatnot. So, is there anything else I really need to tell you about? No, I don't think so. If anybody wants the internet, because they're getting terribly bored and want to check their email, you can log on to Talk Events, who own this fabulous building, and the password's there as well. So without further ado, let's go on with what I'm going to talk to you about, if this thing works. So I'm going to talk to you about Google prediction, and I'll explain what that is in a minute. So my name is David Simpson. I'm an intelligent systems engineer here at Qubit. So I work upstairs in this building. I've been told that this is a job title that needs some clarification. So just to make sure that we know what we're talking about here, I'm an intelligent systems engineer, not the much more embarrassing intelligent systems engineer. So first, a disclaimer, because I'm talking about a Google product. I don't work for Google, and I never have. So I'm not particularly biased towards Google. I think they're a pretty cool company, and I like what they do, and I like their approach to a lot of things, but I don't work for them. This is a pretty, as candid as I can be, sort of account of our experiences with Google prediction. So what is Google prediction? Seems useless. So it can be summed up, I guess, in this sentence, and it's black box machine learning from Google. So the black box element means that you don't actually get to see what's going on. You create your training data and you provide your training data to Google, and you never have any idea what kind of algorithms, what kind of learning algorithms are being run over it. So that's the second point is machine learning. So you've got a black box interface that you're going to use to train a model for whatever kind of prediction or whatever kind of predictive system you need to build. And lastly, it's from Google. So the way that they advertise themselves is it's Google. You're using Google algorithms. We've got a team of Google scientists who are building these algorithms for you, and that's their big selling point on this system. So what does it claim to do? What can we do with this thing? These are things that are suggested, or that Google suggests that it can be used for. So you can build recommendation engines, you can do spam detection, sentiment analysis, behavioural prediction. So you can do a real broad range of the kind of things that you might want to make predictions about. So how is it used? So this will actually give you a little bit of insight into the day-to-day use of how you might actually use this thing. So essentially you create your training data. So you in the same way that you normally would if you're going to try and train any bespoke machine learning application that you built yourself, you need to compile your training data from whatever source it is. You upload that training data to Google Storage, which is Google's developer resource for data storage. You then make a call to Google Prediction to train against those data, and then once your model is built, then you can send prediction queries. So you have a built model that's hosted on the Google system that you can send queries to, and it will respond with predictions for those queries, how it fits with your training data. And then one of the really cool things you can do is once you've got those queries back, if they turn out to be good, you can if you've gone through some kind of validation methodology, you can then send additional data to your model, and it will gradually improve and it will learn over time. So there's two main kinds of predictions that you can make. The first is regression, and you might have a data set that kind of looks like this. So you can imagine that you've got You've got a temperature, and the aim of what you're trying to do is you're trying to predict the temperature on any given day, given the other conditions of the climate. So you've got a city, you've got a day of the year, and you've got the weather conditions. So what's interesting here about the whole point of this slide is that you can give as an input to Google Prediction lots of different types of data, but you've got to be a bit smart about it. So for example, day of the year might seem a bit strange. You'd think that actually you've probably got a date. Why would you include day of the year? So Google Prediction only accepts strings and numeric values. They can be integers or doubles, but you've got to do something smart about how you allow the system to work out what you're talking about. If you just give it a date, it won't know that June falls between May and July. So you've got to be a bit clever about it. And what we'd expect from regression is to send the kind of simple query like Seattle 295 cloudy, and we'll get a numeric response of a prediction of the temperature. So the other kind of prediction that you can do with this thing is categorization. So you might have something like this, where you're trying to build a spam filter. And to build a spam filter, you might just have a description that says whether something's spam or not, and you've got a subject line. So you build a data set that looks like this, pardon me, and what you'll send to it, just to give you a bit more of an idea of the kind of thing that you can send, you send a query like massive discount Rolexes, and what it'll return is it'll return the most likely category that falls into, but you'll also get a list of all the scores of all of the different categories. That's kind of a new feature. They didn't used to do that, and we had little ranks of them, and they put that in for us. So, the structure of training data. So, the way that you build your training data is really simple, or rather, the way that you need to upload it is very simple. It's a CSV file, no larger than 100 megabytes, and generally, you have this kind of format where you've got a single line, and the first column is the value that you're trying to predict, and then the future values can either be numeric or text-based, and they can be. You can have as many of these features as you like, as long as they're consistent in number all the way through your training data. So first, saying a bit more about training data, because I know maybe it'll seem a little obvious, but being smart about your training data is the key to getting this to actually work. Because you don't have any control over the algorithms, there's nothing you can do, and you've got no idea of exactly how your data is being used. The only thing you can do is try and be smart about the training data. For example, the thing with the day of the year. It may seem a little bit obvious, but it's worth saying anyway. The more examples, the better, and the more features, the better. So the more possibility that you provide the system for understanding what you're talking about is better. Google recommend that you should have 10 times as many examples as features. So a feature being one column in your CSV. And from our experience, I think you need quite a lot more than that.
Combinations.
Sorry?
Combinations.
Yeah, absolutely. Also, as an example of sort of some of the subtle nuances that you get, the text features should all be similar lengths. So if you're trying to categorize tweets, it's no use providing learning documents that are all that are all far longer, or that are entire web pages of content. It just doesn't work nicely. Luckily enough, the documentation's got loads of good advice. The documentation is now really good for this. It wasn't when we started out. Most of the time we had to learn it ourselves. So how do we actually use it? Well, there's a complete RESTful API. It's just the way that things should be done. There's a RESTful API. You just make posts at it. Also, there's client libraries for all of your trendy languages well, maybe not all of your trendy languages, but all of the big ones are represented there. So the burning question, I guess, is it any good? And I guess I wouldn't really be here if it wasn't, but it really is. It actually works. And if you're smart about your training data, and if you can invest a little bit of time in getting your training data right and having a think about how it should work, it's a lot faster than just building a bespoke machine learning application. You don't need to worry about how that application is put together or what kind of strategy you should take. It's a really good first step to just throw your data into a system and see if there's a quick solution for it. For example, one of our systems operates at about 91% accuracy. which as a first go is really pretty good. So unfortunately, because Google are a big corporation and nothing in the world is free, you actually have to pay for this. Now, luckily enough, there's a free quota. So it's free for the first 6 months once you sign up. And you can do 5 megabytes of training a day, and you can do 100 predictions a day. Which, lucky enough, they pitched it just at the right level to actually give it a go and have a little play with it. And I strongly encourage you all to do so, because it really is good. After that, it's not ludicrously expensive. You've got to pay $10 a month for a product, for a project. Training is really cheap. You get 10,000 free predictions every month, and then after that, every 1,000 predictions costs 50 cents. And you're limited to 60,000 predictions a day, but I've been told that they can be flexible about that and ramp that up if you've got higher demands for it. So what's next? So I tried to coax out of Zach Goldberg, who's the guy who's in charge of this, and tried to tease out of him what they're doing next with this. And all they can tell me is that in the short term, the goal is to improve the accuracy. So they think that we're on version 1.3 now, and I think that with that, they've pretty much got most of the features in there that they need to have. So until version 1.3, for example, you didn't have a confusion matrix for categorization, and then now that's in. And things like I talked about earlier with being able to get the scores for every category for a categorization task. So generally they think that they've got enough features for now. Now is just time to improve on accuracy. And that's it. So thank you very much. It was a short introduction to something I think is really cool. Give Google Prediction a Google and try it out, because it's actually pretty good. And the sort of what you can do with the text component of it is actually pretty cool. The first thing I tried was to come up with was to build a system for doing movie reviews. So got a load of movie review data, which is used quite commonly on the LinkPipe website. Use the movie review data which has textual movie review with a star rating. That was the training set, and then gave it more textual movie reviews, and it predicted the star rating for that. And sort of once you actually see it working, and all you've had to do is put the data set together, actually think, well, actually that's pretty cool. Like, I don't have to do any work here. I don't need to know anything about AI or machine learning to like leverage this kind of stuff. So it really is pretty cool. So you should all give it a try.
Sorry, what was predicting? Was predicting the rating based on the text?
So in that case, it would give you a number between 1 and 5,
okay.
based on the text query that you sent
right,
it.
that's interesting.
And it would predict roughly how many stars it would have.
In the movie industry, there's actually a business that makes its money out of taking scripts and then predicting how much money they will make.
Yeah, I'm actually asking that because we did a small test on that, like using the Rotten Tomatoes.
Okay?
And we didn't see a high correlation between text and the stars.
Oh, really?
So I don't know. Just interesting.
Oh, that's really interesting.
Okay.
Can you get any information from their system about correlation coefficients between data sets and any of this kind of under the hood?
No.
It's completely.
No, it's the blackest of black boxes, hence the theme of the presentation. it really is. You get nothing, you've got no idea. Yeah.
Have you tried to do it the other way? With the predictions the other way?
With stars to text? No. Sorry, go ahead.
Given what you said to this gentleman over here, what happens if you don't really know what the best data to give it is, and then at some point you want to change your schema, like you want to give it, okay, let's try it in different columns, that 100 megabyte file?
So that's kind of exactly what you have to do. It's very much trial and error. Luckily, it's better now, but you can't. So once you've trained a model, you can upload new data to that model, and if you're going to just replace all of the data, you can have whatever schema you like. It doesn't matter, and it doesn't matter about the order as long as it's formatted properly. So that one project you can just change around as much as you want. But the problem is you don't get any help to refine your data set from, you've got no idea whether two variables are just perfectly correlating, so are utterly useless to you. There's no insight into that, which is a shame, but that's the way the cookie crumbles.
So you'd actually have to try two different data sets, one with the variable and one without the variable, and then look at how accurate the predictions were.
Yeah, exactly.
Do they have any data sets? I'm not even waiting for you to.
Yeah, it's fine.
Do they have any like training sets that you can use, for example, for sentiment analysis? I imagine there might be some.
Yeah, so Google suggests a few training sets, and they've got a few demo ones. So one of the demo ones, their Hello World example is for predicting foreign languages. So you have English, Spanish, and French, a data set of different languages with examples of each. And the idea is that you give it a text string and it'll tell you what language it's in, which is pretty cool. Sorry, you have a question?
Yeah, just out of curiosity, what does your company use this for?
Can you tell so the input that we analyze with it is exit feedback. So it's we have a product that's like a box that pops up as people are. It looks like they're about to leave a web page, and it's a free text box. So instead of being an annoying survey where you say, oh, you know, how do you strongly agree or strongly disagree with this bizarrely irrelevant question? It's just a free text box. What do you think? Can you tell us why you're going? It looks like you are. And obviously it's just free text, people type everything into it. It's really, really useful, but it's really hard to leverage that data. So we use it to analyze that, which is as much as I can tell you. Yes?
Are you giving any rights to the data over to Google by uploading it?
It's interesting you should say that. So, no, you still, let me get this right. You still own it, because we were worried about this too. We were worried that Google would just taking our training sets and going, ha ha ha. They keep it and they store it, but I can't quite get this right. I don't think they're even allowed to look at it. I think they say that they will never look at it or do anything with it, but I can't remember. But it's there to be found, and it didn't worry us, so we're fine.
Is that very much like what they did with the Google Voice, namely that they say they won't look at it, but they're using the training from the data in order to enhance their own algorithms?
I get the impression that might be exactly what they're doing. So they're saying that they're not using it, but actually, in some way they are.
They're using it, but they're not
using it.
Yeah.
They're not expecting it. They're not expecting it.
Yes.
Yeah.
I have another question, but to comment on that, these data sets are pretty amateur, and I don't know what they would do with it. It'd have to be really valuable to actually make a difference to something. But I don't know,
yeah, I guess the problem is that it might have confidential data in there.
Which is another issue, yeah.
But if you have to pay for training for that.
The 91% accuracy thing, the system. What was the system, and how did a human judge that after it was predicted?
Yeah, I can't tell you, but yeah, we validated it by hand.
Right.
So I've had